In today's lesson, we're going to learn how to identify functions. Functions are special types of relations. But before we get into that, let's just recap what a relation is. So a relation is just a relationship between two sets of numbers, or two sets of data. In the example we did the other day, we looked at the temperature over time. So for example, at the first hour, it was 80 degrees. There's a relationship there between the amount of time that we watch the weather and the temperature. At 2 hours, it was 88 degrees. At 3 hours, 85. And at 4 hours, 70 degrees. So that's the relation because we're relating two sets of data. We organized this into something called a mapping diagram. And the way the mapping diagram worked was that we would put our input data, which is our x values of the ordered pairs, into the box in ascending order. So 1, 2, 3, and 4. There's our hours. But we also had to do that with the temperatures too, in ascending order. So the first number in the y box is not 80, it's 70. Then it's 80, then 85, and 88. So these boxes are used to organize the values, and we do it in ascending order. Once we have the values organized, then we can map the numbers, which means we're going to draw arrows to the numbers that go together. So for example, 1 went with 80, 2 went with 88, 3 matches 85, and 4 matches up with 70. And that's how we map the relations. So that brings us to functions. What is a function? Well, a function is a special type of relation. It's a special type of relation where each input has one unique output. The example that we have up above is a relation that is a function. Each input has one unique output. What that means is that the 1, that's our input, x is our inputs, has one output. It leads to 80. The 2, that's our input, leads to one unique output, just the 88. The 3 leads us to 85, just one output. And the 4 leads us to 70. So the example up above is a relation and it's a function. Remember, a function is a special type of relation. So let's look at some examples and we'll determine if these relations are functions. So we have a set of data here and we're going to input this data, this set, into our mapping diagram. Remember, x is our inputs, y is our outputs. So here's an x, and that's my y. So the first one I'm going to enter in is a 1. And I notice right away, in the second point, I have another 1. I don't have to enter it in a second time. I've already got an input of 1 in my box, so I can just leave it there. I enter in the second different input, which is the 2. And then 3. So this covers all of my inputs. We had 1s, a 2, and a 3. Now we're going to enter in our outputs. We've got 20, 25, 26, and 28. So everything's entered in ascending order. And now we have to match them up. So the 1 went with the 20, and the 1 went with the 25. So right away, I can tell that this is not a function because the 1 doesn't have one unique output, it has 2. So in this situation, this is a relation, but it's not a function. We should continue mapping it out regardless. So 2 to 28 and 3 to 26. So this example is not a function. It is a relation, but it's not a function. In our next example, instead of being given a set of ordered pairs, our ordered pairs are arranged in a table. So we're going to determine if the data that we have here, if this relation is a function. With so much data, it's easier to do this a lot of the times by creating a mapping diagram. So let's create a mapping diagram now. So we start with our x values, which are the inputs, and our x values are up here in the top row. So we've got -8, -7, -6, -3, 2. The 9s appear twice, and 10. Put a box around it. So with the x values ordered from least to greatest, now we can do our y values. And the least greatest number is -18, then -16, then -15. I like to just check them off as I've done them. Then -4, then 8, then 11, and then we have 13. And we put a box around these like that. So with everything in the input-output boxes in order from least to greatest, now we can go ahead and map them. We'll draw our arrows across. So the -8 went to the +8. The -7 maps to 13. The -6 maps to -18. So far so good. This is a function as of right now because each input has one unique output. -3 to 16, 2 to -15, 9 to -4, 9 to 11, and I can stop right here for a second. Look, the 9 leads to 2 outputs. So this is not a function. I'm just going to draw the last arrow. We should always finish off the mapping diagram. The 10 goes to the 13. So this is not a function because the 9 has 2 outputs. Not a function. 9 has 2 outputs. So this relation is not a function. We have one last example to look at. So we're going to see if this ordered pair is a function. And we're going to start by organizing our boxes for the mapping diagram. So in order from least to greatest, we have -8, -7, -6, -3, 2, 9, 10, and 11. And then we'll do our y values. So the least greatest is -18. Then it's -15. Then -4. Then it looks like we have 8, 11, And 13 appears 3 times, but I only have to enter it once. So there's my mapping diagram, and now we'll finish it off by connecting the arrows. So -8 matches to 8, -7 to 13, -6 to -18. So far so good. Each input has one unique output. The -3 to 13. So if you're thinking this is not a function, it is a function. It's okay that we have two inputs going to one output. This is okay. The 7 only has a 13 as an output. That's the one unique output. The -3 only has one unique output. It's okay that they're both 13. 2 goes to -15. 9 goes to -4. 10 goes to 11. And the 11 of our input goes here. So this is okay. This is a function, even though we have this here. So remember, the definition of a function is that each input can have one unique output. And in this case, each input does have one unique output. So that's how we identify functions, and that's our goal for today. As always, if you guys have any questions or if you're struggling, please don't hesitate to email me, and I'll get back to you as soon as I can with feedback for you. Good luck, guys.